the 13th problem set, but not unlucky for you, hopefully. Hopefully you'll have got these all right. Okay, so off we go. We're going to start off with a bit of sketching curves, and we're given a curve with this equation here. So that's a reciprocal curve. It's 1 over x. It's been transformed by a stretch of 3 in the y direction. And here we've got a straight line, our old friend. So sketch the graphs of C and L indicating clearly the coordinates of any intersections with the axes. So this should be nice easy marks for us. Now let's consider this one first. So I know that the graph of 1 over x looks like this, and this is a multiplying thing, so it's going to have been stretched, it's not going to have been translated at all, and if you stretch that, whichever way you stretch it, you're not going to get it to cross over the axis. How do I know that? Well, if you divide, the reason it doesn't cross over the axis here is because if you put in x equals 0, you get a divide by 0, which is undefined. So, and this is obviously still, if x is 0, it's undefined. So we can basically draw ourselves this shape here in safety. If you weren't sure what to do, you might actually do a bit of plotting at this stage. You might actually come up with a table of values and get a feel for it. Now, this one here, the y-intercept, so when x equals 0, you can see that y equals 5. So that's our first place, 0, 5. So that's up here somewhere. And then the second axis intersection is going to be with the x-axis, and that is the line y equals 0. So when y equals 0, this slot equals 0, so x would be equal to minus 5 over 2, which is over here somewhere. So that is minus 5 over 2, comma 0. And then we can draw the straight line through it. There we go. And this is a sketch, remember, this is not plotting. You are not being asked to draw it accurately. And that's our 3 marks. So I think we've done it, we've sketched them, we've included all the coordinates of the axis intersections. Now for part B. Find the coordinates of the points of intersection. And this is really, really straightforward, as long as you remember that if you want to find the intersection of two things, you just set them equal to each other, or you solve them by substitution. And you can see here are 2 equations, y equals 3 over x and y equals 2x plus 5. They both equal y, so I can write 2x plus 5, which is y, equals 3 over x, which is also y. And what I'll get out of this, I'll get the x value, that is the x value of the intersections. So first I'm going to multiply through by x, so that gives me 2x squared plus 5x equals 3, and I see it's a quadratic, and I'm thinking to myself, how does a quadratic come out of this? Well, you can see there's going to be 2 intersections, sort of one here and one here, so that's why there's two values. So 2x squared plus 5x minus 3 equals 0, and the reason we set it equal to 0 is so that when it's in factorised form we can solve it. Now, always try factorising first. Here we've got the number 2, that gives us very limited options, it's got to be 2 and 1, and again 3 is a prime number, so it's got to be 3 times 1, so we've only got 2 options really. And I'm looking at the 5, and I'm thinking, how do we get 5 out of this? Well, I can see that 2 times 3 would give me 6, so the 2 times in the 3, and then I've got 1 there, and it's a positive 5, so I need a positive 6, so 2 times positive 3, and then minus 1 times x will bring it down from 6 to 5. And then this means that we've either got 2x minus 1 equals 0, in which case x would be equal to a half, or, and this one's the easy one, x would be equal to minus 3 to make this bracket 0. Now, those are my x coordinates, I need my y coordinates, and I'm going to get them from, well, it's either equation. I'm going to pick this one here, so y is 3 divided by x, so y is 3 divided by a half, and that's 6. So that's my first intersection. There we go. Probably should have closed my email first, shouldn't I? So we've got a half, comma 6, and then with this one, y is equal to 3 divided by minus 3, which is minus 1. So our second one is minus 3 minus 1. Now let's just put them on the graph to see if they make sense. So a half is going to be, it's obviously this one we're talking about. So a half and 6 up. Okay, that doesn't contradict what we've done before. So that's a half, 6. And then minus 3 minus 1 gives us this one. And again, that doesn't contradict it either. We weren't asked to plot them on there, I just plotted them on there as part of my approach to getting a better understanding of what this is all about outside of the narrow confines of the question, and as a result, it gives me a bit of a feel for whether I'm doing the right thing. Now, on to some core 2. Pardon me. Okay, well this is a bit of a beast. It's a big question, not one you want to ignore, and we've got a whole bunch of stuff going on here. So before we even read the question, I'm just anticipating the sort of maths that's going to be involved. We've got a wedge of a circle. We know in core 2 there's arcs and sectors, so you need to know your formulas for them or how to work it out. I've got a triangle here, and we also know in core 2 there's the area of a triangle. It's not a right angle triangle, and we also know in core 2 we've got trigonometry, the sine rule and the cosine rule. So, off we go. First of all, we're going to find the length of the arc BC, so that's this bit here. So we've got arc length. Very, very straightforward bit of maths here. So arc length. Now, you can remember the formula for this. Personally, I always think of it as a fraction of a circle, and this is 0.8, that's the angle here, out of 2 pi. So that's the fraction, and it's a fraction of the circumference, so it's a fraction of 2 pi r, so 2 pi times, and the radius is 7. And you can see that those two cancel there quite easily, and 0.8 times 7 is 5.6, which you can do even without a calculator, and that's going to be centimetres. So that is 2 marks. That was pretty straightforward. You just have to remember it's a fraction of a circle. Now the area. Well, same thing really. It's a fraction of a circle, so it's 0.8 out of 2 pi. Only this time it's a fraction of the area, so it's a fraction of pi r squared, so pi times 7 squared, and you can see the pi's will cancel, and if you pop that into your calculator you'll get 19.6, and this is square centimetres. So nice straightforward bit of maths there. Now we get on to the bit where we're going to earn our C's, B's and A's and A stars. The perimeter of R. Well, if we just go back to this, the perimeter of R, well, we've just worked out this side here, this is 5.6. This side here, DC, if we just go down to DC, it says it's the midpoint of AC, so that means we can work out that quite easily. That must be 3.5, because this is a radius, isn't it? Now, the length of the side we're looking for is this length here, and as you can see it's part of this triangle. So we're looking here really at the sine rule or the cosine rule, and this is a cosine rule problem, and the reason for that is the cosine rule requires an angle and the two sides that are immediately adjacent to it. So when I see this kind of set of 3, if you like, 2 sides and an angle in the middle, I know that I can use the cosine rule. It's not a guarantee that's the right thing to do, but it's certainly a big hint. So let's work out the length of dB, I believe it was. So length of dB. Cosine rule, so a squared is equal to b squared plus c squared minus 2bc cos A. And just remember that the b, c and a in the cosine rule do not necessarily match up to the b, c and a in your picture. It happens to be that we've got angle A, this means this side would be little a because it's opposite it, and these are our b and c, and it doesn't matter which way around we do them. I know we've got a b here, but it's just the two adjacent sides. So let's substitute. So we've got 3.5 squared plus 7 squared minus 2 times 3.5 times 7 cos 0.8, and we need to make sure we're in radians mode. Very careful about that. And if you type that into your calculator, you get the number 27.11137 and some more. And remember, that's a squared, and so to find out the length a, that is the square root of that, and that comes out to be 5.21 and a bit more. Now, that's not the answer we're looking for. We're after the perimeter of R, so we have to add our sides together. So we've got that side, we've got 5.21, and then we've got to add the 3.5 and the 5.6, which is the curved side. And if you add them all up, you get 14.3. So let's just run through that. We've got our 5.21, which is the one we've just worked out using the cosine rule. We've got our 5.6 and our 3.5, and that's our perimeter. Be careful here, we've got three significant figures, well, we've done that, and units. And it's not squares, it's perimeter, it's just plain old centimetres. Okay, now for the area. So the area of R, that's it's a weird shape. The basic principle here is very straightforward. We've got the area of the sector, and if you take away the area of the triangle, what's left is that area there. So we are going to do the area of the sector minus the area of the triangle, and that's going to leave us the funny little leftover bit that's R. Now we know the area of the sector, we just have to work out the area of the triangle. So that's very straightforward. So area of the triangle ABD, and we're using the sine, area of a triangle using sine, which is a half BC cos sine A, so it's a half 3.5 times 7 times sine 0.8, which gives you 8.79, and that's centimetres, so it's square centimetres, which means the area of R is equal to 19.6. That's the area of the sector. Subtract 8.79, that was the area of the triangle, which leaves us with 10.8, and it's 3 sig fig, and that's the area there. So that is the end of that problem, I believe. Yes, it is. Hope you had fun doing it and that this was helpful.